Hot ice demonstration. The materials needed for this experiment are 4 cups of distilled vinegar, 4 tablespoons of baking soda, isopropyl alcohol, water, a strainer, a pot, a dish, a glass container, access to a stove, microwave and refrigerator, and food coloring, which is optional. The first part of this experiment is to produce sodium acetate. To start out, I pour 4 cups of vinegar into a pot. Next, I add 4 tablespoons of baking soda to the vinegar. I do this very slowly to prevent it from fizzing over and making a mess. Once all the baking soda has been added, I stir the solution to make sure that all of it has reacted to form sodium acetate. Then I heat up the sodium acetate solution on the stove at medium heat. When only about half a cup of liquid remains, I turn off the stove. I carefully pour the hot solution into a glass container. Then I waited for the solution to cool down to room temperature. I was surprised to find that sodium acetate crystals had already started forming, even though there was only a moderate change in temperature. I placed the container into the refrigerator to try and get the rest of the sodium acetate to crystallize. After 45 minutes, more of the sodium acetate did become solid. The remaining fluid did not have much sodium acetate left in it, therefore I could just pour it off. And I used a strainer to make sure I didn't lose any of the crystals while doing so. The next step was to wash away any impurities that might be remaining using concentrated isopropyl alcohol. It was important here to use alcohol instead of water because water would have redissolved the crystals and I would have been left with the solution again. By now, the sodium acetate was quite pure, but there was still a lot of alcohol in there, so that needed to be completely evaporated before it was exposed to any type of heat. I spread the sodium acetate out across a dish to try and increase the surface area so that the alcohol would evaporate faster. Additionally, I used a fan to increase airflow. All I had to do now was transfer it to a dry container. Part 2 of the experiment is to actually make the hot ice. I separated out some of the sodium acetate to be made into solution, but I made sure to leave some, as these would serve as seed crystals to allow the hot ice to solidify. The next step was to add a small amount of water to the sodium acetate. I was careful not to add too much, as this would result in a solution that would not solidify. I also added a little bit of food coloring to the solution. The microwave was used to heat the solution until it reached a boil. Next, I carefully placed the solution into the refrigerator for 45 minutes to cool. The final step of preparation was to put a few seed crystals onto a dish. To make the hot ice, I either poured the solution onto a seed crystal, or alternatively, I put a seed crystal into the solution. When I put my finger into the hot ice, I could feel that it was actually quite hot, despite just coming out of the refrigerator. This final attempt of the experiment was not sped up at all. The chemistry behind hot ice. The reaction between sodium bicarbonate and acetic acid can be represented by the following chemical equation. One of the products is C2H3NaO2, which is sodium acetate. This is the compound that makes up hot ice. When a very small amount of water is added to the sodium acetate and heated, a supersaturated solution is produced. This means that there is more solute dissolved in the solution than the solvent can hold. An increase in heat causes an increase in solubility, since the added kinetic energy allows the ions to more easily overcome intramolecular forces and dissociate. This allows a large amount of sodium acetate to dissolve in a very small amount of water, causing the solution to become supersaturated. When the supersaturated solution is cooled, the solubility decreases again. The sodium acetate wants to come out of solution, but can't, since it does not have a point to start crystallizing from. This point is known as the nucleation site. Until a nucleation site is provided, the sodium acetate remains in solution. When the supersaturated solution is poured onto the dish, the seed crystal becomes the nucleation site that the sodium acetate needs to begin crystallizing. Since there is so much solute dissolved into such a small amount of solvent, the sodium acetate very rapidly crystallizes and becomes solid. Also, despite the fact that the solution came out of the refrigerator, the hot ice is quite warm, as the name implies. This is because the process of crystallization is exothermic, meaning it releases energy. Particles have a greater average kinetic energy as a liquid compared to a solid. When the sodium acetate rapidly solidifies, it must release some of its energy so that the molecules can come close enough together to form a crystalline structure. This release in energy is the reason that hot ice heats up as it solidifies.